Okay, I am taping a video on the Quiz One review just in case we're out for another Cyber Day. You can find the quiz review in the content section, or there is a link in the news feed for the Cyber Day. We are going to try to have the quiz as soon as we can when you come back. So make sure that you have gone through and know all your stuff so you can ask questions when you get back to school. So reading the disclaimer at the top, it said this applies to every review for the whole entire year. Do not just study this review. This is not an exact copy of the quiz, nor will any of your test reviews be the exact copy of the test. You're responsible for any and all materials we have covered in class. Just because it is not on this review does not mean it is not on the quiz. Look back at all the notes, practice, and classwork in order to be completely prepared. You will also be expected to apply your knowledge to new problems on the quiz and tests that come in the future. If you understand the basics, you should be able to figure out the new problems. So the first part, numbers 1, A and B, start out very, very easy. Basically, it's making sure that you understand that the diameter of a circle is twice the radius, or the radius is half of the diameter. So to find the radius, I would take the diameter and divide it by 2. So the radius of the circle would be 5 inches. And when I'm given the radius, to find the diameter, I would take my radius and multiply it by 2. So in this case, my answer would be 12.5 inches. The next problems have to do with vocabulary, and you will find that there is vocabulary on the test. Can be pictures, can be the actual definitions, and you have all of these in your packet, as well as I think there's an answer key online, as well as a video that explains them. So the first one we're going to go through, and we have point D is indicated just by the letter D, and that is a point of tangency. So that letter that belongs to is E. Then we have a line, and it is FH. FH is the line. So FH is actually a tangent line. So we're going to put F there. Line segment CD is the radius because the endpoints are the center and the edge of the circle. So that answer is going to be D. Line segment AB is going to be a chord, and it's a chord and not a secant because it says line segment. So B is going to be the answer for line segment AB. It is a line segment with the endpoints on the circle. Point C is the center of the circle, and it names the circle also. We have line segment AD, and in this case, the endpoints are on the edge of the circle, and it goes through the center, so that makes it a diameter. And then line AB, so we have line AB is actually going to be a secant, as opposed to where we had line segment AB, it's a secant because it is a line, so it extends outside the circle. In the diagram for number 9, RS, we're told, is the radius of circle R. ST is a tangent to the circle. And show briefly and explain your answer. RS is the radius. Is ST a tangent of the circle? So we're trying to see, is ST a tangent of the circle? Now, we know that RS is the radius, and if ST is the tangent of a circle, it will form a right triangle. So to figure it out, if ST is a tangent, then RST would be, or triangle RST would be a right triangle. So A squared plus B squared is equal to C squared, where C is the hypotenuse. Where C is the hypotenuse. Okay, so A is equal to 4, B is equal to 12, so I have 4 squared plus 12 squared, and then C is equal to 13, equal to 13 squared, so I have 16 plus 144, and let's see if that works. So 16 plus 144 equals 160, so it does not equal 169. So in this case, ST is not a tangent line. Okay, and then the next one, it says AB and AD, line segments AB and AD are tangents to the circle. And so if you remember looking at your formula sheet, if they are tangent to the circle, these are line segments. They are congruent to each other. So, or I could remember this is a tangent, this is a tangent. It would be 7x minus 2 squared is equal to 3x plus 8 squared. That's the long way. Take the square root of both sides. 7x minus 2 is equal to 3x plus 8. Then I subtract 3x from both sides. 4x minus 2 is equal to 8. Add 2 to both sides. And 4x is equal to 10, and I divide by 4, and then x is equal to 2.5. So, and we can always check because that's kind of a crazy answer. So I do 7 times 2.5, and then minus 2, and I do 3 times 2.5 plus 8. And they must be the same if they're correct. So 7 times 2.5 minus 2 is 15.5. And then 3 times 2.5, 7.5 plus 5, is 12.5. So maybe I did something wrong. So let's go back and look. I'm adding 2 to both sides. So I have 7x minus 2 is equal to 3x plus 8. I subtract 3x, it's 4x. I add 2 to both sides. So 10 divided by 4 is definitely 2.5. So then I say 7 times 2.5 is 17.5 minus 2, it's 15. And then I have 3 times 2.5 plus 8. I think I did plus 5 is 15.5. So this is plus 8. So then we are correct. Moving on to number 11 at the top of page 2, and I need to make sure that you can see that. It says number 11 and 12, TY is the radius of circle T, and YZ is tangent to circle T. Find the value of X and show all your work. Round your decimals to the nearest tenth. So in this case, this TZ is equal to 16 applies to this one over here. I apologize for that. It's the whole segment there. So I am actually, this one is a little bit more difficult, okay, because the TZ applies over here. It makes it a little bit more difficult. So I know that the Pythagorean theorem has to work here. So basically I have a squared plus b squared is equal to c squared. And I have r squared plus 11 squared is equal to r plus 8 squared. And it's not as hard as you think because it's going to end up canceling out. So then I have r squared plus 121 is equal to, and I have to go, I'll go up here to the side and do r plus 8 times r plus 8. Okay, because that's what r squared means, and I have to distribute it. So it's r squared plus 16r plus 64. So at this point, I have to solve, and I'm going to subtract r squared from both sides. And so I end up with 121 is equal to 16r plus 64. Subtract 64 from both sides. Okay, so I have 121 minus 64, and I divide it by 16. And so it tells me to round to the nearest tenth. So r is equal to 3.6 in this case. So r is equal to x, so that is 3.6. So then on number 12 is a tad bit easier because, again, it forms a right triangle because of a radius and a tangent line. So a squared plus b squared is equal to c squared, and we're told that c squared is 16, and I have 15 squared plus r squared. So then 15 squared is equal to 225 plus r squared, and I do believe 16 squared is 256. And then I subtract 225 from both sides. So minus 225, and I'm left with r squared is equal to 31, and then I have to take the square root. And so the square root of 31 is 5.6. So that is r, or x in this case. Okay, so then it says determine whether the intercepted arc is a minor arc, a major arc, or a semicircle of C. So arc DAB. And because arc DAB is greater than 180 degrees, it is a major arc. Arc B, where's B? BD. And I go the short way because it's only 2 letters, and that is a minor arc. And then BFA, because BA is a diameter going through the center of the circle C, we're told that, okay? That is going to be a semicircle. And arc FB here is going to be a minor arc because it's less than 180 degrees. The next one, number 17, it says find the measure of arc MN. So MN, it wants you to find this part right here. Now, I know the center is at this, vertex is at the center of the circle, therefore it's a central angle, and when I have a central angle, angle is equal to arc, so that tells me that it's 135 degrees. We know by this marking that that is also 135 degrees, and then I have to know that the whole circle is 360. So I subtract that by 135 plus 135, which is 270. And so my answer is 90 degrees. And then looking at number 18, I am going to solve for MN this time. And again, my vertex is at the center of the circle. So my angle is equal to my arc. And 160 plus 35 is 195. And so I take 360 minus 195, and I solve for this arc, MN, to be 165 degrees. Then looking at number 19 and number 20, it says find the measure of BDC, so I'm going all the way around, in circle P. Now, I know that the minor arc here is 58 degrees. So actually, all I have to do is take 360 and subtract 58, and it becomes 302 degrees. The next one states QT and RW are diameters. So a diameter splits it into a semicircle, and it wants you to find QW. Okay, so it said RW is a diameter. I know that this is 40 degrees. Okay, so this is going to be 180 minus 40 degrees, which is 140 degrees. Okay, going on to the next page, the final page. This is where we're starting to do work with angle measures and arc measures and segment measures. So in this case, I have an inscribed angle. The vertex is on the circle, so angle is equal to the arc divided by 2, or 2 times the angle is equal to the arc. And in this case, this one would be easier to use. So I have 2, and my angle measurement is 78 degrees is equal to 4x plus 140. And then 78 times 2 is 156 is equal to 4x plus 140. So I subtract 140 from both sides, and I end up with 16 is equal to 4x, divide by 4, x is equal to 4. And then sometimes I will be asked what the arc is actually, and so I'd have to add it together, and so that's going to be equal to 156. This one has to do with the fact that opposite angles in an inscribed quadrilateral are supplementary. So I have 2 different equations here. I have y plus 77 is equal to 180 degrees. And I can solve for y. So y is equal to 103 degrees. And then I have the formula of 2x plus 110 is equal to 180 degrees. And I subtract 110. So 2x is equal to 70 and divide both sides by 2. So x is equal to 35. Number 23, I am trying to kind of do the same thing, not with inscribed, but these are both inscribed angles, not an inscribed polygon. And both of the angles inscribe the same arc and the same arc of y. Okay, and so this is an inscribed angle, so angle is equal to arc divided by 2, or 2 times the angle is equal to the arc. So knowing that the angle is 40, the arc has to be 80. And because these two have the same intercepted arc, x has to be 40 also. So that's 40 and that's 80. 24 has to do with the fact that the diameter, BC, because it's going through the center of the circle, cuts the circle in half. And so that means that this is 180 degrees. And that also indicates, because the vertex is on the circle and the endpoints are the diameter endpoints, that this is a right angle because it's half of the arc it intercepts. So knowing that, then I have the triangle sum theorem, and I know that y plus x plus, 57 degrees is going to equal 180, and I know what x is. So then I can solve for y by, that should be a plus sign, is equal to 180, and then I take 180 and subtract 147 from it, and y is equal to 33 degrees. So 33 degrees, and x is 90. 1, it says that the vertex is on the circle, and so the angle is equal to the arc divided by 2. So the angle is equal to 140 divided by 2, and that is 70 degrees. The next one, 27, I have a vertex inside the circle, so the angle is equal to the sum of the arcs divided by 2. So I have 65 is equal to 36 plus x divided by 2. I multiply both sides by 2. So 130 is equal to 36 plus x. Subtract 36 from both sides. 130 minus 36 is 94, is equal to x. And then the last one on this page is has to do with the fact that I have two tangents. So there's a relationship between this and angle 1. And so if I know this arc right here and I add it to angle 1, they are supplementary. Okay, and I can find out what that arc is, the small arc is, by taking 360 and subtracting 236. And that arc measure is 124 plus angle 1 is equal to 180, and then I subtract 124 from both sides, and angle 1 is going to equal to 56 degrees. Now, this review does not have any line segments on it, or segments of a circle. So use the review for that portion of the quiz was your information that you did Wednesday night for homework and Tuesday night for homework. So good luck and study hard.